Hi. Okay guys, this is a new chapter. Skipping a couple of chapters to go to chapter 12, solutions and the dissolving process. The homework here is the same policy. It's going to be due on the day you take the test. You will upload on that day of the test. So let's get this thing started. We're just going to look at 12A today, and that sounds like a lot of objectives. So let's tear it apart. You're going to be able to describe the parts of a solution, okay? You're going to be able to categorize examples of solutions into their types, okay? And there's three basic types. You'll be able to explain the dissolving process. You'll be able to explain why certain solutes do not dissolve in certain solvents. You're going to be able to compare the solubilities of different substances. You will be able to describe how a solute can dissolve faster, and you will be able to describe how more of a solute can dissolve in a solvent. Woo! A lot of stuff. I might possibly break this into two parts, but let's get going. So when we look at solutions, the basic idea is this: homogeneous mixtures in a single phase. Now, what do we mean by phase? Well, we can talk about liquid. A solution like coffee. Doesn't matter if it's Starbucks or McDonald's or whatever, that is a solution. It's a homogeneous mixture. Homogeneous meaning the same. You look at that, you pour that coffee into a glass, glug, 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 it's clear. You see there, it's all brown. There is nothing different about it, okay? We can talk about another kind of solution that's a solid, where we look at the rings, okay? As far as how many carats of gold do you have, well, I should say, yeah, carats, okay, of gold do you have? 10K, 14K. 14K is a standard, okay? When you get to 22 and 24, it's more bendable and they can break more easily. That's why you have to mix these with a little bit other metals to make it stronger. Okay? So a solution is a homogeneous mixture. Okay? Now there are gas solutions as well. But here, every solution has two major parts. One would be the solvent. That's the major part of the solution. It does the dissolving. But wait, what do you mean it does the dissolving? Okay, let's take an idea, okay? I go, and I have here this cup. It's a wooden box. Okay, and I put that down there. There is the solvent and the solute, okay? The solvent does the dissolving. What does that mean when we talk about dissolving? Well, in order to get to the solvent, you have to understand what is a solute, and that's what's dissolved in the solution. So here's an example. We've got water, we've got blue crystal, and we have ourselves a solution. Don't drink that. So what am I doing with the box? Well, imagine this is the container that you're having your solution. This piece of paper is what's going to get dissolved. I am going to do the dissolving. Well, wait, what are you talking about dissolving? I'm going to show it to you right now. This is dissolving. See this right here? Let me bring that up. See this right here? That was that paper. I'm dissolving. I am the solvent. I am tearing apart this paper. I'm dissolving it, and I'm inside the box too. That would be a solution. So what's in here? This is the solute. This gets dissolved. What's dissolving? You're breaking things down. That's what we mean by dissolving. Okay? And then I am the solvent. That's what makes up most of the solution. It's a solvent. Well, what are examples of solvents? You could look at water. Water is an awesome solvent. Okay? Kitchen science. You have nachos at your house. Okay? And you are generous with the cheese. Let's be honest. You got it on the plate. You know the situation. You had the party. Everybody enjoyed the nachos. There's leftover nachos, but there's cheese that's stuck onto the plate because you crashed after the party. Next morning, you wake up, you see the cheese that's stuck on the plate. Oh no, what do I do? The solvent, water. Just put water in the pan if you want to speed it up, add a little soap. And there you go, ladies and gentlemen. Easy peasy. What does water do? It helps break up the cheese. It does, and it makes it so much easier to clean. Chemistry in the real world. Okay, let's keep going. So what are properties of solutions? The solutes, what gets dissolved, cannot be filtered out of a solution. Guys, I can't filter this out. It's dissolved. It's in such tiny little pieces, I can't really grab into it again. That's the problem. The solutes do not settle out of a solution. Okay? So when you look at coffee, it stays as coffee. You don't see the coffee going to the bottom. Solutions are uniform. They look the same. Okay? Solutions are not chemically combined. That's a very important idea. The other thing is solutions can vary in their concentrations. That's a fairly important idea that we have there for that. Okay? So let's just keep going here. So you now get the idea. You have a solution. It's a homogeneous mixture. You know that the solution has two main parts. There's the solvent that does the dissolving and the solute that gets dissolved. Okay? You know that there are properties of solutions. They stay uniform. The solute does not settle out. Okay? And the solution can be of different concentrations. Okay? But now we're looking at types of solutions with examples. We have liquid, solid, and gas. And for liquid, it's kind of obvious. Soda, coffee, household cleaner. The solid, it's kind of hard to picture a solid as a solution, but the truth is, it is a combination. It does fit the pattern. It is uniform. Okay, if I take off my ring here for a second, and you look on the inside of it, I don't think you can see it, but it's yellow gold. It is 14 karat gold. Okay, this is a solution. It's a solid solution. Even staples are a solution. Gaseous solutions like atmosphere, scuba tank gas, cooking stove gas, all those are examples of gaseous solutions. Okay? Now, liquid. Liquid solutions, excuse me. The solvent is a liquid. That's the basic behind it. The solute could be a solid, a liquid, or a gas. Okay? Now, there's two ways to look at it. There's miscible and immiscible. Miscible, the two liquids can mix and form a homogeneous mixture. Pretty straightforward. A great example of something that would be miscible would be chocolate syrup and milk. That's miscible, right? They're both liquids. Mix them together, that's miscible. Immiscible, when liquids separate after mixing. Wow, what would be an obvious one? Oil and vinegar. They're both liquids, right? When you mix them together, they don't really mix well together. They actually separate. Yeah. So that's immiscible. So miscible, we can mix two liquids together. They won't separate. Immiscible, to quote Taylor, it's like, we're never, ever, ever getting back together. They weren't together in the first place. That's the whole point, Taylor. They weren't. All right. So solids, think like my ring. The solvent is a solid. The solute could be a solid, a liquid, or a gas. Okay? And metal alloys are great examples of solid solutions. An amalgam, think about the teeth filling. It is a solution that contains a little bit of mercury in there. Now, in recent years, they've stopped doing that. They're using other alternatives for it. So we have looked at liquid solutions. We have looked at solid solutions. Hey, how about that gas? Well, the gas, again, the solvent is a gas. The solute is a gas. Gases cannot dissolve liquid or solid particles at normal pressures. Okay? So we can talk about the atmosphere. Okay? The atmosphere, you know, it's got lots of nitrogen, you got some oxygen. Now, they're both gases, and yet they combine. They're not chemically combining, the N2 and the O2, but they are definitely there. They're mixing around together. Okay? So, yeah, they do combine. They can. Okay? So think about natural gas here. They have to add something to make the natural gas have a smell, because natural gas by itself doesn't smell. They added the extra chemical in there so that you smell it, and that allows you to realize you have a gas leak. Okay? All right. Okay. We've looked at solids in liquid form, gas form, and solid, liquid, and gas form. That's what we looked at our solutions in, right? I had a brain out there. Okay, so then the next question is, all right, I take that chocolate syrup, I add it to the milk, I stir like crazy, and how does that work? Well, it's a dissolving process, and that's something called solvation. This is not to be confused with salvation, which is what God offers to every human on the planet through Jesus Christ. He is the only way. He is the Lord sovereign God, and He is salvation. Solvation, it's a dissolving process of solid and liquid solutions. Okay? Well, wait, what do you mean by solvation? Hey, how about powder, cocoa powder and water? That's a great example of dissolving a solid in a liquid solution. Or wait a minute, what about sugar in water or salt in water? All those are great examples that you can see solvation in there. The molecules of solvent surround and separate the ions or molecules of solute. Okay, I gotta check my time here. 14, I get able to do that. How much further do I have? I'm thinking about my time, guys. Okay, so this guy's solvation. Here, let's see if I can call it my. See, this is what I would be able to. I can't do this at home, which is why I'm taking advantage of here. Okay, so when we look at solvation, okay, remember it's solid in liquid. Okay, the solid gets dissolved. Okay, what does that look like? Well, think about this. Here you got all these water molecules, right? you've got all these water molecules that are here, and let's say I am NaCl. So the Cl is a negative, and the sodium is a positive. Okay? Now remember, what do we know about the water? Well, on this end it's positive, on this end it's negative. This is key to understanding solvation. It's a dissolving process. How does it do that? Okay? You remember in the year I've said to you, my chemical romance, this is my chemical violence. Because here's what happens, ladies and gentlemen, and I gotta make sure I got the time to pull this. Yeah, I do. Okay. So, with that, guys, all right, here's your Na with the plus. Here's your Cl with the minus. What happens? Water is smaller. Water will literally surround the molecule. Okay? That's what's happening. The water is surrounding the salt molecule. And if you notice on here, this side, it's the negative side that's in contact with the sodium, right? Here on this side, it's the positive side of the water that's in contact with the chlorine. And what happens? Rip. The water tears apart the salt. It will surround the salt, hook up to it, and then break it apart. It's the same idea for sugar as well. It's a little bit different, but it's the same basic idea. So solvation, you got a solid and liquid. Here's your water, here's your salt. The salt gets surrounded by water. In other words, yo, the salt gets jumped by the water, yo, and salt get the beat down. Yeah, that's right. That's a boomer putting it that way. But that's really what's happening. Water surrounds the salt and rips it apart. Okay? Okay, now with that, I only got a couple of minutes left. I am going to stop here, and I'm going to give you guys a part 2 for this, because this thing will stop at 20 minutes. Okay, I'll see you on the flip side.